Okay, so on the first two examples, we use changing things into sine and cosine. And that is a strategy I am suggesting that we try in this one. It's a strategy you kind of you go to often. And some of the other skills that you need for verifying and simplifying are your algebra skills. So a lot of the algebra skills that we did in the first part of the year in trimester one, getting common denominators, simplifying complex fractions, things like that, you're going to use those a lot here when we're verifying. We need to use those steps in order to take something that's more complicated and make it simpler or easier to handle. So let's start off and try this one. On a problem like this, I'm going to work on the left side because it's more, looks like it has a lot more going on. It might be easier for me to simplify this and get it to something like sine theta plus cosine theta. I'm going to try the strategy of rewriting tangent and cotangent in terms of sine and cosine. So I'll start off here, sine of theta. Tangent, I'm going to rewrite as sine theta over cosine theta. Cosine theta over cotangent. Cotangent, I'm going to rewrite as cosine theta over sine theta. So I'm working to simplify this to sine theta plus cosine theta. I now have these two complex fractions, and I need to clean those up. I don't want to leave them like that. So I can really think about it as this is really just saying sine theta divided by sine over cosine, and cosine theta divided by cosine theta over sine theta. So how do we do that? We're going to really write this as a multiplication because division's really just multiplying times the reciprocal. So I'm going to take sine theta and I'm going to multiply times the reciprocal. I'm going to take cosine theta and multiply times the reciprocal. I just like to put these over 1. This makes me super happy at this point. I'm glad that I'm able to simplify this. If I simplify that, it cleans it up nicely, and I can kind of see where I'm going to. I have cosine plus sine theta left. I can rewrite this as sine theta plus cosine theta. And I've now shown or verified that the left side equals the right side. So that one we're using some of our algebra skills. What's important on these problems that you show every single step. When I'm looking at your homework or worksheets and grading these, what I'm looking for is all of the steps. How did you get from the left side to the right side? So you need to make sure that you're very clear. If you don't show the steps, you're not going to get the credit on these homeworks and worksheet assignments. So on this one, I split this one into two. I'm going to show you how to do this two different ways. Like I said before, there's not just one way to do these. How I might see something, kind of the approach I start, if I just kind of go down a path, maybe my path is longer, but I'll eventually get to the same endpoint, which is verifying the sides. Sometimes you just hit a roadblock and you don't know where to go. You have to erase and start over again. So I'm going to start here, and I'm going to show you how I could work on the right side. This is how I would probably naturally do this problem. I would work on the right side of this problem just because I wouldn't know really where to start with sine over. It's not as straightforward on where to start on the left side. On the right side, I can always try changing tangent to sine over cosine. So I'm going to use this right here and say, well, this is really sine theta over cosine theta, 1 plus, I'm going to change sine theta over cosine theta. Kind of running out of room. I didn't give myself much room. Okay. So now we have on the bottom, 1 plus sine cosine theta. I'm going to take, and I want to try to get common denominators here. So I need a common denominator of cosine. So I'm going to multiply 1 by cosine theta over cosine theta. If I do that, I'm going to end up with sine theta over cosine theta all over cosine theta over cosine theta plus sine theta over cosine. So I needed to get common denominators so I can combine that denominator. So now I can rewrite this. It's a lot of rewriting. I can rewrite this as sine over cosine all over cosine theta plus sine theta. My common denominator is cosine, so I can combine those together. So now I'm starting to see something, right? I'm looking on the left side. I need a sine theta on top and a cosine, a sine theta plus cosine. I'm seeing that I have both of those. I have the sine theta here. I have the cosine plus sine. I need to clean up this complex fraction, and it'll probably get me where I need to be. So if I finish this off, this complex fraction, I'm just going to multiply times the reciprocal, so I get sine theta over cosine theta times cosine theta all over cosine theta plus sine theta. So this works out. Now I am starting to see how it's coming together. I can cancel my cosines, and so I'm going to end up with sine theta all over cosine theta plus sine theta. So I'm showing how these two are equal. So that's one approach. Okay, I feel like that's the most straightforward approach. I will show you here another way I could do this one is I could think about multiplying. Another way I looked at this is multiplying everything by 1 over cosine. So what does that look like? And I don't think this is as straightforward, but I'm thinking, how can I get tangent on top? I can multiply 1 over cosine. I can multiply sine by 1 over cosine. That's going to give me tangent. And then if I multiply sine by 1 over cosine on the bottom, I'm going to get tangent, and I need a tangent on the bottom. And if I multiply cosine by 1 over cosine, those are going to cancel, and I get my 1. So this is definitely quicker. If you see, I'll get sine theta over cosine theta all over sine theta cosine theta plus cosine over cosine. The top's going to give me tangent theta. The bottom's going to give me tangent theta plus 1. So really, I've now shown that the two sides equal to each other. Both are right. I think the first way is more obvious, but somebody might see that, and you could also work through the problem by multiplying everything by 1 over cosine. Just to keep the videos not so long, I'll do another video for the very last example.